Thank you. The floor is yours, Lars.
Thank you. This presentation is a little different. It has nothing to do with embedded programs. I'm going to be talking about making command line interfaces using the CLAP crate, CLAP as in command line argument parsing. It's not the name of a disease. My name is Lars Wirzenius. I'm old. I have URLs. On the side, I do some Rust training for money. I have business cards if anyone's interested, or if anyone knows someone who might be interested. At the moment, I have code running on 2 planets. I don't know of more than 2. I'm also a little bit of a snob when it comes to command line usage. There are programs that I refuse to use because I really don't like their command line interface. Sometimes this means that I write my own program instead. Why should you care about command line interfaces? You should care because your users care. There are people other than me who like using interfaces that are easy to use. Not just people who use Macs, also people who use command lines. The interface guidelines for what a nice command line interface is like vary. For graphical user interfaces, entire libraries have been written about this, but not so much for command lines. So whatever I like is good. You should also care because you're going to be using your own software. If you're not using your own software, shame on you. Unless it's accounting software. Unless it's accounting software and you're an accountant, then you should be using that. Anyway, a good command line interface makes it less likely that the user will make a mistake. For example, I have used a program that copies a file from one directory to another so that the target directory is given first and then the source file. I came from Unix. This was not a Unix system. Guess what mistake I made? I will never get that file back. If you write software that has other users and the interface is hard to use, they will ask you for help. And nothing ruins a Sunday morning when like 15 emails saying, I don't know how to use this program. You wrote a README and everything, but still they get it wrong. If you write commercial software, then ease of use, a nice interface is a commercial benefit because your competition is stupid and will make a bad interface. Unless they're here, but hope for the best. Also, it turns out that a nice interface when using CLAP is easier to maintain than a crappy interface that you wrote code for yourself. Some more details about that. Any command line program that doesn't have a dash help option is buggy. No exceptions. If it has subcommands, it should have a subcommand called help. There should also be a -h short option because some people don't like typing. I don't like typing, especially not on this keyboard. The command line interface implementation should also check for typical errors in what the user writes, so that if they have extra arguments or other mistakes that they make, then they get an error message rather than a mystery, and they don't know what's happening because they thought they were doing something and it didn't happen, and my youth was misspent. The interface that the program implements should conform to the conventions of the environment where it's being used. I only use Linux. I'm not well versed in Macs or Windows. I used to use MS-DOS. If nobody ever sees MS-DOS again, that's fine. Ditto VAX VMS. The conventions I show here that I'm going to be mentioning are for Unix. The history of how the Unix command line interface conventions have evolved over the decades, it's bad. In the mid-1970s, early 1970s, in Bell Labs, where Unix was originally written, they had an internal enormous flame war, as in people talking loudly at each other. This was before email. This was before Facebook. About what the options should look like. One camp went, no options ever for anything. The other camp went what we now call short options. And they would not buy lunch for each other. This was an enormous fight. The camp who did not like options had good points, but they lost. Who of you have used curl? Almost everyone. When I checked this morning, curl has 255 command line options.
Is that the maximum?
No, just at the current, there's no maximum, there's no table that gets filled. It's just a lot of options. I'm not sure that's a good number of options. 256 would clearly be better. So I'm going to have to go home and make a patch. One of the things that happened in the early 1990s was that the GNU project introduced long options. Not like this. The GNU project said that a long option starts with a plus. So according to that, this would be not dash dash whom, but plus whom. And then they lost to POSIX, who for some reason made this impossible. But GNU changed, and dash dash is what's being used. And for the convenience of users, things like if you have an argument to an option, it can either be a separate command line argument or be separated with an equals. Users really like this. As someone who has implemented this syntax, it is horrible. You should feel bad for the people who implement command line parsers. The benefit of the original Unix short options is that parsing is really easy. Are there anyone here who has learned the C language from the Kernigel and Ritchie, the C programming language book? A few people. It has examples of how to manually parse the command line. For decades, this is what all C programmers did. Until someone thought about this and, hey, we could write a getopt function. And then GNU wrote a getopt long that handles long options as well. Having this in a function is excellent because writing all that code for every program separately, I'm a little opinionated. It's stupid. Having written that in too many languages, too many times, it's not what you should do. An invention from later is subcommands, where you have run a program and it has commands instead of options on the command line, and it might have options as well. Git is an example of a program that does this. Git is not the first one. Git came in 2005. It was preceded by a number of other Unix programs like SCCS, one of the first version control systems that also does this. But since nobody uses SCCS unless they're really, really old, even older than I am, Git is the example that people know. Subcommands are nice because if the program, what it does is complicated, then it's easier to have subcommands than a very complicated option syntax or multiple programs. Git, of course, has both a complicated command line syntax and multiple programs. The original 1970s Unix short options, the argument was whether it would be okay for a program to ever be able to do anything but just one thing. So the people against options were of the opinion that if you have a sort program, there's one sort program that does sorting one way. And if you want to have it sort case independently, that's a separate program. The other people were of the opinion that you don't need an option for this. Either will work. If everything is a separate program, you have a very large number of programs. But that happens. So I'm now going to show a couple of ways of implementing the first approach without subcommands, and then one implementation of the subcommand approach in Rust. These are not complete programs, but they give you the flavor. And there will be no points for people noticing bugs in this. I had to fit it on a slide. In the Rust standard library on line 3, you see a way to get an iterator over all the command line arguments. And in order to parse those, you iterate over those and see if the command line argument is what you want to have. On line 4, you skip the name of the program because that's always the first one. And then you check if the command line argument starts with -- whom equals. And if so, you take the rest of everything after the equals, store it in whom. Or it might be without an equals, and then you just set the flag that the next argument is whom. Or if the previous argument was -- whom without an equals, then this is what we save. And we give an excellent error message if it's something else. Clearly, that error message is not up to Rust standards. However, this is basically what all the C programmers written in the past 40 or 50 years have been doing. You made an error, go away. Slightly better phrased, but I had to fit things into a slide. This is handling one option, one long option, with or without an equals. Imagine doing this if you have 255 options and you don't have a library. Daniel Stenberg probably would write this fine because he is an excellent programmer. I would just take up woodworking. But this is doable. If you really don't want to use a library, then you can do this yourself. If you want to write your library or write a library yourself, that's fine. I'm talking today of CLAP because that's clearly by far the most popular one. There are at least 2 dozen other ones that I have found. Where CLAP has downloads in the millions and tens of millions. These other ones have tens, which is fine. Sometimes you just write a crate for yourself, that's fine. Not everything needs to be popular. But if you're not interested in writing command line parsing code yourself, just use CLAP. This does the same thing using CLAP. CLAP has a type call command that we create. We give the name of the program to new as an argument, and then we use an this is a builder pattern, so it creates a new argument whom, where the long option form is whom. This is a little confusing. And it has a default value. Default values are really nice because sometimes the user just wants to use the thing that doesn't want to use an option, they just want to have something that gets greeted. And then getMatch is actually parses the command line and returns a type which is not shown here because it's implicit and we don't need to. But the matches value has a method for looking up using this name, and since there's a default value, it always returns something. So if we just unwrap that without testing, and if there wasn't a value, then this panics, that's fine. But because there is a default value, that we don't panic, and then we greet whoever. Is this approximately clear? Nobody raises their hand. That's fine. This is meant to be clear.
So can the argument for new be arbitrary, or is it actually tied to the name of the argument?
You mean this one? That can be anything. However, whatever you give here is what you need to use here, because this name is just for the option. This is the name of the value of the option. This gets a little complicated if you have not written command line parsers. There's a difference between the option and the value of the option, for reasons that is clear after reading it 100 times in C. This will work. It's not too bad. If you have 255 options, it gets a little long, especially if there are more things to specify about options, not just default values, but allowed values and maybe ranges and so on. But it's doable, it just gets a little long. This is the thing why I like clap. There is a derive mode of using clap where we import a parser macro and we use that for deriving, and this takes a structure definition and generates code to parse exactly that kind of command line. So we have one long option that has a default value that is stored in a string. And then when we parse the command line, we can access the value of the whom option just using structure fields. If it happens that, let me go back. In this case, if we make a typo here, that's fine for the compiler. The compiler doesn't understand this string. What happens is that at runtime we get a none, which means that the unwrap will panic. And users don't really like panic messages from programs. In this case, if we typo whom here, that's a compile time mistake. The compiler will catch that because it's trying to access a structured member. This is, once you have 255 options, it's big. And this program is a little longer than the previous one, but the structure here is so that if you want to add lots and lots of options, you could just basically add a couple of lines here for each option. It's very repetitive. The structure of the code is really clear. It's easy to understand. It's even easy to understand if you're me and a little tired a Sunday morning. This does generate code using derive macros. I don't care. I have disk space and memory. It might matter for embedded cases, for example, but those usually don't have command lines. The previous embedded computer I programmed for ran an Oracle database server. It had 512 gigabytes of RAM. It had command lines. It was crazy. I would not have called this embedded, but it was embedded in a machine that eats mountains. Literally eats mountains. Right, so subcommands. Subcommands is something that is also easy to make with CLAP with the derive approach. The idea is that you define an enum that lists all your subcommands, and then you match on an enum, a value of that type, enum type, and then do different things. I've kept this simple, so this is fairly straightforward. But here is we change the arg struct that defines the whole program's command line interface, and this time we declare that CMD is a subcommand. And the type of the subcommand must be an enum that derives subcommand, and it has hello, hello, and goodbye, goodbye. So the variant hello contains a value of type hello. And if I could have figured this out, I would have had a third hello because I grew up in the 70s. And I enjoyed hello, hello, hello. Nobody else understands this because there was a program by Neil Hardwick for teaching children English that was called Hello, Hello, Hello. I need to explain all of my jokes. So the hello structure looks like this. It also derives parser because it parses the command line. It defines a whom option with a long name and a default value. And then we implement the run method for this hello. And this just happens to print the greeting. The goodbye version is the same. They're literally almost exactly the same, except for some names and the message being printed. The other important bit here is the documentation comments. These are a big change. In the previous examples, there wasn't any help text defined for the options, because that would have required writing long string literals, and I'm lazy. With the derive macro, these documentation comments become help text. And those comments are much, much easier to write and format in your text editor or IDE or whatever, so they're preferable.
Does it support Markdown?
I don't remember if it supports Markdown. In theory, why not?
I think what goes in log is your writing, so the macro picks it up. So if it doesn't have its own Markdown format.
Right. If it doesn't support Markdown, then someone should make a patch. So examples of how this looks when a user runs this. There is a clap always defines a -- help. Also -h as an alias. And this text comes from the docstring. There's subcommands with docstrings, and an extra help subcommand because that's also good practice. Some people are too lazy to write -- help. They just want to write help without dashes. I'm not saying I'm lazy, but I'm lazy. And if there were other options that would come before the subcommand, then they would be listed here automatically. Or you can look at the help for a specific subcommand and what options it might have. So there's almost like a built-in help subsystem compiled into this. It also tells the user what the default value for whom is, which is really nice. And there's some examples of how this actually used. If you just run hello, we greet the world. Otherwise, we tell the hello command whom to greet. This is earth-shattering complicated, but anyway. And then there's some error checking. If we don't give any subcommand, we get the help text. That's even shorter to write than help. And if we give too many arguments, that's an error. So there's an error message. And I have some Rust training. But before we go there, any questions?
So if the user typos their arguments, does it work as well with the extra arguments, or?
So if the user says hello with one L, yes, that then you get an error. Sorry, then the user gets an error message saying, "I don't know this subcommand. Maybe you meant this." If I could dare to make a live demo, I could actually check that.
Yeah, it suggests you similar option.
Yes.
Now we need to go to the right. Unrecognized command, similar subcommands, help and hello. They all start with H, so clearly they're similar. These are all fairly easy to do if you write your own command line parser. But the total number of fairly easy things to do gets a little large once you start taking this seriously. And with CLAP, you don't need to write this yourself. A number of people have spent a lot of time taking this part of the Rust ecosystem really seriously. There's even helper crates that build on top of CLAP to do things like generate manual pages automatically, or tab completion files, and so on. I would not be surprised if there's an AI subsystem for CLAP. But I haven't checked. Any other questions? Excellent. I thank you. You were a great audience.